We're on to day 3 of similarity, which is actually unit 6, not unit 7. Today we're going to talk about that proportionality thing, the idea that two similar shapes have a proportion that holds between them. We can use that to solve for unknown side lengths. We're going to take that to and apply it to some similar triangles. Okay, so here's the first thing. You probably want to pause to write some of this stuff down and to record things as we go along, and that's fine. Just pause it and write stuff down and then go on. Okay. We have something called the Triangle Proportionality Theorem. And the Triangle Proportionality Theorem says this. If you have a line that's parallel to any side of that triangle, so in this case I've drawn a line that's parallel to the base, it divides the other two sides proportionally. Okay? So in other words, if I know that this line here and this line are parallel, the sides that it cuts in half, it means that these two sides here to here and here to here, they follow a proportion. In other words, A to E is to EB as AF is to FC. Okay? And that stays right here. Notice as you record this down, as you write this down and you look at this, E is a point. E is the point here where the intersection is. F is the point where the intersection is. B, C, and A are the corners of the triangle, right? So we're talking the length of A to E is proportional to EB. We can set up a statement. That is, as long as that line is parallel, okay? Now, it doesn't have to be the base necessarily. Maybe I could take this and I could rotate it this way, right? Okay? So now I'm not talking the base anymore, but I have a line that's parallel to another line, to one of the sides of the triangles, and it cuts these other sides proportionally. Okay, that's the Triangle Proportionality Theorem. So let's go through and let's use that to find a missing side length, perhaps, right? Find the length of PN. That would be this here. Let's go ahead and put an X in. X doesn't represent anything else right now, but that's going to help us visualize what's going on, right? All right, so here's what I know. This line and this line are parallel. That means whenever this cuts through the other two sides of the triangles, that'd be these two V shapes, right? Okay, that means that this 3 is to X, 3 is to X as 2 is to 5. So I can write a statement like this. Now all I have to do is cross multiply. That gives me 2X is equal to 15. And I can divide out the 2. So X is equal to 15 halves or 7.5. And to be honest, I mean, since you're going to have to, you better get used to this. Let's just call it 15 halves, okay? It's 7.5 is what it is. But let's call it 15 halves. Leave it in that format because that's what you're going to have to do later on in your Algebra 2 classes, right? Okay, so there's one example. Pretty simple, right? Here's an example off the ACT. Let's see if I can zoom out enough, okay? In the figure below, A lies on CQ, which means that A is on this line from C to Q. P lies on QB, so that means it's on its line, and AP is parallel to CB. Aha! So we have this going on, right? If A to P is 5 units long, and P to Q is 3 units long, C to B is 15 units long, how long is P to B? X. That's what we're going for, right? So here's our diagram. This is what we're trying to figure out. Well, to be quite honest with you, I don't even see, you know what, this is kind of in the wrong section of the notes, to be honest, because what this is not necessarily the Triangle Proportionality Theorem. It kind of is because you have the parallel line cutting through, but really, this is just a simple case of little triangle and big triangle. And the little triangle has a base of 5 and a side over here of 3. The big triangle has a base of 15 and a side of we don't know. Right? Now you gotta be careful. You gotta be careful here. The 5 became a 15. Apparently that's 3 times as long, right? So the 3 is going to become a 9. But 9 is not my answer. See, 9 is the total length of the entire triangle. And herein lies one of the biggest mistakes, the most common mistakes that is made on this problem. If you miss this problem, a lot of people would say 9 is the answer, and that's not the case. Okay? The problem is this little triangle here, and this is the big triangle here, meaning this entire length from here all the way to here, that's what the 9 units represents, right? So we got to be careful. What's that leave for x then? Well, x and 3 have to add up to 9. That means that x must be a 6, right? it's 6 units in length. So that wasn't necessarily a proportionality problem, but it does, it kind of fits in because it does deal with parallel lines cutting through the middle of a triangle. At any rate, that's kind of how you do one of these problems. Okay, 5 to 15 is equal to 3 over x. I don't know. I mean, that doesn't work, does it? Right? It gives us a 9. So just be careful on that. When you're done with this, I think I've got 3 or 4 videos on this. They're all pretty short, but that's the first video over applying the proportionality idea.